Is 9:24. We're just a little bit out, hopefully, from the launch of Artemis. I'm first warning meteorologist Eric Burris, and joining me is Mark Berger. You are a launch weather officer with Space Launch Delta 45. Obviously, we're going to be talking about weather. So far, so good in weather, but just tell us a little bit about the overall kind of launch forecast for tonight from at least an official element, if you don't mind.
Yeah, so really the concentration on weather began before the tanking began, so that they have a special weather constraints for tanking.
Right.
And those of course have been good, no lightning around, so we're good there. And of course the all-important launch. So right now we're looking at only a 10% POV, so that means 90% favorable conditions. I look upstairs here and just see a few high, thin, wispy clouds.
Yeah.
Not a concern at all, so as long as nothing moves in from the west, we're good from a weather perspective.
I love that. Now, the rule that was of concern was the thick cloud rule, I believe it was?
Thick cloud layers.
Right.
Yep.
Okay, so tell us a little bit about that and why that exists, I guess.
Okay. Yeah, so most of these rules have to do with electrification of the clouds. Some of that you see right away with the glamorous lightning strikes, but a lot of times you do not. And so one of the criteria that we look at and assess is the criteria for so-called triggered lightning, which means you send a very quick-moving vehicle through a cloud. Some of those clouds can actually help develop a charge. The so-called thick cloud layers rule is really pertains to certain types of clouds at certain altitudes that are at least 4,500 feet thick.
Right.
And so we were actually registering on our radar earlier tonight to a depth of around 10,000 feet deep near Tampa. So we technically would have been no-go if we were actually evaluating for a time earlier this evening.
Yeah.
Right now we're go.
Okay, that sounds great. And then looking ahead to tonight, hopefully that will continue as long as. Let me pull up the enhanced satellite while we're discussing this, just to make sure. And certainly the satellite is GO 16 and it's not looking at the different layers, but hopefully we'll continue to be good. It's the meso channel, so it's gonna take it a second. Which, by the way, very nice of them to put the meso channel right over top of us, right?
You like that? We did that for you.
Did you?
Yes.
Did you put the ask in?
Well, there's a freestanding request for that. Our launches. So.
Well,
yep.
That's cool. Of course, it's going to take forever because it's so much data. We're not going to get it.
But what you can't see is that there were some thunderstorms over the Gulf. We were getting some of the wispy anvil clouds coming over to the west coast from that. Not a concern for us, but we had some of the rain up north of us actually did spill some of that lower cloud deck into our area earlier tonight.
There's the satellite. So it's all associated with a frontal boundary, and you can actually see on the satellite there the thunderstorms that are off the shoreline. So thankfully, the timing should be good that has no gauge on us.
Right, that has no threat of introducing any sort of lightning or associated rule violations for us with that cloud.
All right, so as everybody's joining us, if you have any questions, we've got Mark Berger, a launch weather officer, who is far smarter than I will ever pretend to be. So
come on, Eric.
you've got an expert here. So ask the question. Lindsay's asking what time is the launch. So we're targeting 1:04. Knock on wood.
That is the beginning of the 2-hour window.
Yeah. So we've got a 2-hour window there. Let's see here. Won't be long now. That's right. Sarah says, "I hope it launches. I'm going to stay up for this." You're staying up for this?
I better.
I'm staying up for this.
Otherwise, I'm not going to get paid. Right?
Yeah. Well, there's me too. Yeah, me too. So yeah, we're doing good. Brandon's asking, will it be clear tonight? Mark, I see a couple of stars up top.
Yeah, so mostly clear skies. Again, just a very thin, wispy cirrus up there, which would not be a concern for launch.
Perfect. I love it. So we're looking good. Hopefully that will continue. Just to let you know, Mark will be joining us on CW18 tonight. So we're going to be talking with NASA Administrator Bill Nelson. At least that's what we're hoping to do. And then looking ahead to 10:30, we'll be discussing launch weather with you on CW18. 11 o'clock, just hits, runs, and airs. And then starting at 12:30, we're going to be doing kind of our whole coverage thing. Kristen's asking, is it going to be clear from New Smyrna Beach? Things are looking better and better for viewing around town.
They are. A little bit more cloudiness to the north, certainly, but again, I think we're going to continue to see a trend of it thinning out. So kind of just a haze layer, if you will, upstairs, but still shouldn't prevent a pretty good launch.
If we've got the most powerful rocket to ever launch from the Kennedy Space Center going up tonight, at even a haze layer, I feel like we should be able to see this thing go up, right? John's asking a great question. What does it take to become a NASA meteorologist. Now, you don't work for NASA, but what does it take to become a launch weather officer?
So a degree in meteorology would be the first step, and then a lot of perseverance. I mean, I got here after working in the National Weather Service for almost 2 decades, and so I just kept trying and trying and trying, because this was my childhood
This
dream.
was what your target was?
Yes.
So how long did it take you to get to be here?
Well, really, I only knew about the job exactly for a few years, so a couple of years it took me, but like I knew right away from, when I saw the job vacancy that this was it.
So you wanted to do this specifically. Talk about what do you do? For anybody that doesn't know, like, what is a launch weather officer?
It's kind of a fancy way of saying a meteorologist. So basically a lot of the same training that you would have in school, I have in school. The only difference was that, I went into government, very early in my career and went that way. But always just a keen interest in the space program and astronomy. And of course, meteorology helps a lot too. So
you cover the launch forecast, like this, for example. This is the forecast that came from your group, SLD 45. That 90% probability of good weather, that comes from your office essentially. So you're looking at, talk about 90%. Like, how do you come up with that? It's easy to say, like, oh, it's a 50% chance of rain, because it's a wide swath of an area, but you're talking about pinpoint, like this dot in this minute of time. How do you come across your percentages? How does that all work?
So it's art and science. There isn't a machine that pumps out numbers that we use. So we're looking at a lot of the different so-called weather models. We're looking at what's called MOS, model output statistics. Those give us numbers, but they're not numbers that actually would do anything to help us come up with a percentage here. It's just basically a situational awareness and kind of say, okay, what are the triggers that may make worse weather? So a lot of it's actually just experience that's gained over time. You're like, okay, this pattern lends itself to bad weather for launch. It lends itself for cloud cover of the kind that we oftentimes see with precluding launches. So that's where the number comes out. It's actually again, part art, part science.
So here we are. This is just kind of a look at where the current status is for the wind data off of 39. So this is the graphic I was telling you. So we've got like a nice southeasterly breeze. Winds up top gusting to 19 miles an hour. Winds kind of mid-rocket, 15 miles an hour. And winds at 130 feet, running about 12 miles an hour. So that's all within constraints, because the constraints are what, 35, 45, I believe?
They vary by the altitude, and some of it's proprietary, but if we have too high of winds at liftoff, we can't launch. In fact, even if the sun is misbehaving, we can't launch. So there's certain criteria beyond what you see with the glamorous clouds or lightning. There's actually more criteria that we look at, and what the sun is doing is part of that too.
Talk about that if you don't mind.
So it's basically considered solar flux. So the sun puts out energy, and certain particles that come out have the ability to interact with spacecraft components, the electronics, as it ascends through orbit. So occasionally, and it's very rare, but of course we're heading into a solar upswing now towards solar max. We're going to see the incidence of this increase, certainly.
How do you do? That's out of my realm of forecasting. So I'm going
satellite
to be,
data.
Really
Gives us a read on what the current state of the atmosphere is. We actually have other meteorologists that work at the NOAA Space Prediction Center, among other Department of Defense entities that are actually forecasting that. So we borrow their forecast. We're not solar, astronomers or meteorologists, but so we have partners that kind of look into that aspect. But the sun actually can make us no-go for a launch.
I've always seen it. I've never known, and I know that there are people that have asked that question, and I never have had an answer for that. So, wow. All right. So talk about experience. So how long have you been with SLD 45?
3.5 years.
Okay. Your first day, it's your dream job, and you're bright-eyed and bushy-tailed, and you have an experience behind you. You're no fool. You're no green rookie here. What's it like on your first day on the job? All right, we're going to teach you how to do the weather for launches. What's that feel like to you?
To be honest, it was actually overwhelming. And like you said, kind of borrowing back on past experience, I used to go out on forest fires, and for all the fire teams that you see like a mountain on fire out west, they have a federal meteorologist there. So I used to do that and was accustomed to pressure and having to produce the best forecast for life and property. But this was just totally different, and it was something completely different aspect of meteorology. For instance, normally we use radar to interrogate where it's raining.
Right.
We do it here to actually look at cloud edges.
That's wild.
So there's so many different things, and then all of these different rules, or lightning launch commit criteria is
right.
what we call these 10 rules that we basically look at to decide whether it's safe to launch through clouds
right.
or not. And they have very many offshoots to these rules. So like it's almost like a diagram. If this, then you can't do this.
Right.
If this, maybe you can do this. If this and this
wow.
and this. So like learning those and not necessarily memorizing, but learning them and then trying to understand the patterns.
Sure.
Florida is also an interesting place to try and predict the weather
yes,
too.
Yes, it is.
And I'm saying that as a Midwesterner, but it definitely, Florida has its own complications as well.
Yeah.
It took some getting used to.
So when you take the data, there's at least, there's 9 sensors on Launch Complex 39B. There's a whole wind farm though out here. Can you talk a little bit about the profilers that you guys use as well?
Absolutely. So like when we look at wind, weather towers which go all the way up almost to 500 feet in terms of measuring actual observed data.
Right.
And so we use those obviously to get a pin on what the actual wind constraints would be
right.
for a liftoff. But there's so much more than that. We have a profiler that actually NASA owns and maintains, and that particular profile actually sends up a little radar beam up to 60,000 feet in the atmosphere every 5 minutes. And that data can be used not only to give us an idea of what the state of the atmosphere is in real time or nearly
right.
real time, which that actually helps to forecast loads that the vehicle will encounter
sure.
in the sense of the atmosphere.
Yeah.
And you think we set up weather balloons too, and they gather a lot of the same information, but of course a weather balloon drifts off-site,
right.
and it also is much more discrete in terms of the time.
Mm-hmm.
It isn't really real-time data,
right.
and it takes 90 minutes to get up through the atmosphere. So we have a lot of tools at our disposal, and all of those are used not only by the launch weather officer
right.
to say, okay, we're within our wind constraints, but also for the customer, in this case NASA, to decide, okay, are these safe loads
right.
for the vehicle to ascend through.
Do you find that the weather balloon data lines up to that profiler pretty closely?
Pretty closely,
wow.
yeah. The weather balloon data is higher resolution,
sure.
So it's definitely has been in the past more the go-to or
right.
first read of things,
right.
but yeah, the profiler that we use, the radar profiler here at KSC, is just it's unbelievable for real-time data, and it's measuring directly above our heads rather than a balloon that drifts with the wind.
Where else would you find a wind profiler like that?
Well, this is the most sophisticated amount of weather instrumentation in the entire world is right here at KSC in Cape Canaveral.
I did not know that.
Yeah.
Okay. That's super awesome. Anybody have any questions, by the way, while we're chatting? It's super cool. People are saying their eyelids are already closing. Very cool. All right. Any final thoughts from because this is a group of weather nerds. So we're all in good company here. Yeah. So if anybody's interested in not taking your job, but maybe
please don't take.
Yeah, but maybe one day when you're starting to slow down, and they want to join you, what would your best advice be to someone who's interested in that sort of thing?
This is a very niche part of meteorology, and meteorology is a very specified field
right.
it is. So luck, does play into it, and no doubt. But I would say actually for a lot of people, taking a career in the military, in the Space Force, is probably your most likely opportunity, and they get to do so many cool things and serve our country as well. But that's probably the most, quote, guaranteed pathway to get here. But as a civilian like me, it's, again, kind of going through the standard degree at a university, and then, putting in applications. Working and hoping.
Love it. Very cool. We'll talk to you at 10:30, sir.
Absolutely.
Thank you very much. There you go. All right, very cool. So we're looking good. 90% chance of good weather. We'll see you in just about 22 minutes or so on West 2 News on CW18. Bye, y'all.